moment, I'd like to deal with one project in Perth. It's an office tower called QV1 for some obscure reasons. It's a building that was commissioned to contain 60,000 square meters of rentable office space. And the criteria were that the building should respond to its location. And I think what you can see here is, of course, the skyline of Perth. St. George's Terrace is its main street down the business district. This is the actual site. And you may recall hearing about the implosion of these two buildings. They were sort of done away with very quickly by placing charges and making it all fall inward. It's a very effective way, if they let you do this kind of thing, to get rid of unwanted structures. What is unique in that location is that it looks not only onto a beautiful view of water, Swan River and the basin to the south, but also to the west. There's a huge park here, Kings Park, and in the foreground some of the remarkable planning that was undertaken in Perth, and I think it's to the credit of people of decades ago who had sufficient foresight to really plan roadways effectively and reclaimed in parkland, and it's really quite beautifully landscape, forms an excellent foreground to the city proper. In designing commercial office buildings, we have found that the tenants as they exist in this country are highly responsive to outlook. Analysis has found that office space that has clear water views, I think this applies to Sydney as much as to Perth, command much higher rents than office spaces that look onto other buildings or look the wrong way, unattractive outlook. It has quite a dramatic impact on the rents that these buildings command, and they're in the neighborhood of 15 to 20% more for those that really have stupendous views. What that brings with it is a demand on the part of the client for an architect to design buildings that really maximize his asset. I'll quickly take you through the process of elimination of how one goes about, at least how we went about trying to achieve this. This is the site here, and there's St. George's Terrace going down the middle of Perth. This is all this landscaped area I spoke of, and Kings Park and the water, of course. Magnificent panorama that exists southward of the site. If you try and build, let's try different shapes and see how much of the floor space, and these are all buildings that would be some 40 stories high, contain a core that has maybe 20% of the lettable space. The lettable space is column-free and has something like 14.5 meters span from the core to the outside. And let's see how they respond to this basic idea of having people look at this desirable orientation. The round plan doesn't feature very well because, as you can see here, there's less than 50% of the people really look at the water. And we don't mean like craning your neck to look out sideways, but you look straight out the window and what do you really see? A rectangle isn't much better because it's obvious that the sides of such a building look into adjacent properties, the back looks the opposite way, and only well, you know, maybe a third of the space of that looks at the at where you want to see things. Now you turn it on its side, 45 degrees or so, it's better. Probably 50% of the building will see something, but it's still a bit difficult because this broad side doesn't really look at, it's almost too long, and as it happens, there are tall buildings on this side. The view is somewhat predicated looking that way, and it's not entirely satisfactory either. You can try a square on the 45 degree, it's better. But again, you can't claim that any more than 50% success rate. Now, we did a building in Brisbane that had a similar disposition in that it was on the water's edge and people wanted to see water obviously there. And we made a building that's triangular in shape in order for the two broadsides, so it's 2/3 of the building, looking up and down the river, and thereby, in long view, getting water views, and that was considered satisfactory there. We tried that in this case, and there's something wrong with that because there's no water right here, and there's an adjacent building here, low, although it's low, but this angle is too steep to really claim that these people have a desirable water view. Now, to just summarize why this was considered desirable. Maximized outlook, to minimize northern outlook. There's very few people who really don't see the view. From there, these people don't. But if you take that depth, and if that's all glass along here, maximum number of people see just what you want them to look at. This plan lends itself to a repetitive, identical, clear span floor system, which is very important to get a building up quickly. An efficient core. Core is 20% of the gross, 20% and 80% visible. And the core, of course, is placed against the very side where you don't desire an outlook. Centralized core doesn't make sense in a situation where you are keen to get that dominance. So it makes sense to pursue that. One of the criteria also that was an input into this process of elimination was the desire on the part of the authorities, which is spelled out clearly, that from the nearby Parliament House, which is on top of the axis of St. George's Terrace, a broad side should be avoided. So the building was required to show its least dimension toward Parliament House, and not a blank wall, they said, please. So it responds to that also. The result is that the building does have, and here's the view from Parliament House. You can look down St. George's Terrace there. This is the barrack arch, as they call it, at the end, and a very unattractive a lot of end walls facing west. Of course, people tend to want to put blank walls there to avoid high solar intake. So here's a superimposition on that that shows these buildings in the foreground that have been built since. There's the long axis, and the building that turns away really and puts on their sharp edge toward the view from Parliament House. This was one of the criteria also set down for consideration. And finally, from the water, the building does expose its broad face toward the water, and that was, of course, sought after. Now, let's have a look at what it really looks like. That's its view from the south to show the shape of the building and the way its windows are exposed on these two broad sides. And here's a plan. The plan shows that the building is placed on the southern end of the site. The site is this large rectangle here, and the northern part of the site, adjacent to this pedestrian precinct, which is Hay Street, shopping all the way along here, has been opened up to become a pedestrian area. An enclosed or rather shielded plaza places then the building at the southernmost extremity with the main approach. Taxis pulling up here, you'll be able to get into the building without getting wet. It's a canopy that you can see here, extends right out to the alignment. Now what I think should be a byproduct of building such huge amount of floor space permitted by the laws as they stand is that elbow room, or somehow space has to be made available to the public, of course, on private land. This is so often ignored in present day sort of edicts of local government, which seems to be in the mode of asking for every building should look the same as the one next door, and build right out onto the face of the site and surround the site totally with building. If you have a tall building, let it grow out of the roof of such a low structure, and I think that makes very little common sense, because it does rob the city of elbow room, and that is the first thing we really do need when we build such high concentrations of population. People have to be able to go somewhere. There has to be desirable outlook and amenity for those who look out of the building. And the building, of course, will be set up much better by being set in a landscape environment. But at the same time, there is a need and a reasonable request to maintain certain shopping facades which exist along there. So there are low structures adjacent to the tower where they make sense. They're there, but it is open, although covered. You'll see that in a minute, to reveal this new publicly gained public open space. And I show this picture always, which is just outside the door here at 5 o'clock in the afternoon. It's horrendous, really, what happens when people do build right onto the street with buildings that have an index of 12 or 14. Where are people supposed to go at lunchtime? I mean, it's just induces an indignity, I think, to people, and that's what really everybody complains about our cities. And I feel one of the answers may be a very careful and age-old facility of the right kind of screened and enclosed open space, covered or open to the sky as the case may be, to give some respite for those who live in these buildings and have some amenity as a compensation for the increase in population, this enormous density that's suddenly implied. And there's nothing new in that. This, of course, is Australia Square, which is now 25 years old, and it's still a place that people like to go to because there's food available, there are fountains, trees, places to sit, and that's what cities have been doing throughout the ages. Here's a picture of Siena of the Middle Ages. Those of you who go to Europe always marvel at the delight of the open spaces in cities where people eat outdoors, public functions take place, and this is adjacent to the inevitable narrow lanes and comparative tightness of the rest of the urban fabric. So this was really the guiding principle of design of this project. Here's one that, well, you saw that before from the other side, but that's the kind of public spaces that I'm talking about, that are not bluntly open to the sides or to the street, but are somehow visually and screened so as to make people feel comfortable and secure. Nobody likes a widened footpath. Nobody will linger there. Nobody will sit down there. Or being adjacent to the traffic, both noise and pollution of traffic. Nobody wants to linger on a widened footpath, and that's so much misunderstood, I think, in some of our rules and regulations. Several people reject. They say that's useless, therefore let's build right out to the street facade. But when it is secluded, I think it makes a lot of sense. So here we have the plan, the upper floor plan of this scheme that has that opening from it's open to Hay Street. That's the other way. There's Hay Street here, and that's the entrance that we saw. There's a large openness in this plaza, which is on 2 levels. People can enter into that space. They can go up to the upper level of it, and that becomes an integral part of the tower. And it is also connected to a 1,000-car garage, which is built across the street and connected by bridges. There's a detail of this from the north that you can see now what I mean by this space here not being bluntly open to the footpath. It is screened, it's open to the footpath, and yet it is covered so that you walk under this undercroft and you public space is revealed to you. Not only does that make obvious sense from a wind point of view, and Perth is a very windy city. This is the leeward side. Wind comes from the south or southwest. So this is a comparative shadow of the wind. But it will, on 2 levels, make possible desirable outdoor activity. There's to be a theater, it may not actually happen there, but there's restaurants, shopping, and waterfall fountain. Water forms the basis of all those, some trees, of course, growing out of this quite mature kind. And here you can see that for the desirable orientation, we open a slit so people can look out where we want them to look at. But up here, there's a sense of containment in that we don't want people just to be able to look at some unattractive facades or whatever happens on the other side of the street, but rather their attention should be drawn inward. And this, by experience, I found to be the key to having these places become popular. People like to have, as it were, cover on their back in Australia Square. You put these screen walls slightly raised above the footpath or above the street where the cars are. If you're away and you have the back covered, people feel like relaxing and staying. And this is what you actually see from the footpath. Walk, as it were, under a portico to reach that, similar to the way you walk under that plaza building in Australia Square onto the plaza. Without it, I think it would not nearly be as desirable. Now let's talk about the building and get down to the nitty-gritty of the structure. First of all, the geometry. In order to, or if one has in mind for a building to be built economically and speedily, I think there must be a very rigid system of dimensions about this, which will enable formwork to be systematized and go up quickly. You can see what happens here, the radius of these corners here, these 3 places where there's a quadrant inserted there, there, and there, obviously follow the same dimension as the main span from the outside to the core. The core is, of course, done rising form, and the entrance of the building is an interruption to that system, or the system doesn't really get going until it gets to the first typical floor. The reason for that is, I mentioned that people want to be able to have cover to get into the building. You can see it there. But also for an appropriate scaled opening to yield the desirable effect of such a big building, where the entrance to the building should be, or should, I feel, must be in appropriate scale to the height of the building. In other words, not just a one-story kind of space, which would be the most economic thing to do, but inappropriate for the kind of imagery that these sort of buildings demand. Now, you may notice that the building, of course, isn't just a curtain wall. It's not just filled with glass, and I have a great belief in the fact that we live in an era of intense escalation of energy costs, which may be getting worse with present-day news. And I think it makes undeniable sense to protect our facades, although we want them to have glass, and it's the only thing that will give us the kind of views and downward outlook that is desired from these major areas of the floor space. But by putting awnings or the right kind of protective device on the outside shading, it will do 2 things. First of all, we'll obviously save energy because we'll keep the heat intake during hot summer months down, but also it will be unnecessary for that building to be equipped with Venetian blinds, which would be totally absurd, where one minute you're trying to chase the view and the next minute you're going to cover it up with Venetian blinds. And I just think that would be unfortunate. There's nothing new in that, again, because if you look at our history, our forebears, I think we're a little more intelligent than we are. This is a Queensland building of the 19th century, and even the little window there, they were aware of the fact that there's intense ultraviolet light in our climate here, and they even covered that quite attractively and beautifully with an awning. Well, that's the kind of thing that we, in fact, did on this building, which has horizontal awnings that cover the high rays of the sun, but because they're located facing east and west, there are vertical blades as well that tend to cut down on the horizontal early or late afternoon suns. None of this sun protection is 100% effective if it is fixed. Movable sun protection, I think, is something to be taken with great care. We tried that years ago, and I wouldn't recommend it on high-rise buildings. The maintenance factor is not one that would induce one to use that. But fixed devices, I think, can yield a perfectly desirable result. You can clean the windows by having gantries that luff in and out under these shades, and you can quite effectively clean windows even though they're protected. We've done that in a number of cases. Now, the entrance to the building is, as I say, an interruption to the logical system. The canopy becomes higher to mark the entrance, and there's a great area of glass covering the approach to the building so it doesn't become oppressive, but people can look through that. The way in which the load from above regularly placed columns, you may have noticed that the facade elements are all identical, whether they go around the corner or in a straight line, about 6 meters apart. Two of these columns are simply interrupted. Now, I don't believe in making structures that span, although you can do all kinds of muscle work these days to resist loads. Not all that easy, although our last speaker showed us how 40-story buildings can end up on quite huge beams, and that's very necessary in many cases. But here, it is all visible. It's not something that's hidden. So these legs, these transfer elements that pick up two columns, column here and column here, they become a single turned element against wind resistance, and also they reveal the high lobby, which has got 2 levels of mezzanines opening into it, and you get this huge expanse horizontally and vertically in the lobby, which is sought in order to give that scale that I mentioned. Here it is in construction, and of course it's what you get is something that can be formed with straight forms, because a hyperboloid such as this is, which is to some extent dictated, of course, by structural considerations, is formable with straight line elements. You can make such a form out of straight boards or pieces of plywood. How to cover that finally is something, in this case the building is covered with polished granite, and it's very difficult, one might think, how to get flat pieces of granite over such a twisted surface. But we've done that similar thing here's a detail of that leg. You can see a column here that's stopped, the other one on top of that. And this is the device that turns this dimension into that dimension at ground level. And this is all generated by straight lines, making this hyperboloid or hyperbolic paraboloid surface. In a building in Melbourne, we have covered it, and the closest thing you can do to getting a flat surface, flat, untwisted piece of geometry covering a hyperboloid is a triangle. And it, of course, won't cover it perfectly, but it will cover it rather attractively, I think. So that a similar thing to that is going to be done in this building. The canopy hangs out quite a long way. It's partially cantilevered, partially relieved by some tension members. And a similar thing was done in Riverside. Again, a wide opening created by some gathered structural supports and steel members carrying the loads. Now, to get to the way the building was built, aside from this interruption, once the system gets going, I think the left-hand diagram shows the system adopted. Identical structural spans for the perimeter, whether they go around the corner or not. That means that all the facade elements are the same. The sunshades are all the same. They're just, sometimes you've got them vertical ones fixed on this side, other times you have fixed vertical ones on that side. The same elements apply.
same elements apply even on the north where there's only horizontal ones. When it comes to the structural spanning of 14.5 meters from the core to the outside, this of course is rising formwork, continuous pour. To produce the floors, standardized formwork is used, creating these beams, and the beams, as you may see, don't reach the point of support. They stop at a band that resists shear there and there. And maximum bending is resisted in the middle where the concrete profile is a T. The result looks like that going around the corner, where these spans are identical, so they're virtually interchangeable troughs for beams, interchangeable shear bands, and only a tapered and a straight area of formwork in between these identical beams. This is the profile, and these are pre-stressed floors, of course, for that span, anchored at the core, stressed here, and anchored in the facade beam, and stressed there. You can get at the stressing from the floor, to hang on the scaffold, and these beams that, as I say, stop with this thickened shear band allow for mechanical services to be contained longitudinally, running there and there, within the structure, all along there, without adding to the depth or consequently the height of the building. Here's the partly stripped product, shear band. These beams are not yet stripped. They're back propped for a certain period, of course, until they're ready to receive, to be totally stripped. There are some penetrations left for wiring or plumbing or whatever, any future services that have to traverse the system. But of course, the traversal is possible totally by means of this recess. I can't stress that enough, that the fact that what so often discourages people from building column-free vast office spaces, 14, 16 meter spans as the case may be, is the fact that what do you do with the services? When you start having to need to run longitudinal surfaces through it, and you have to hang all that on the underside of an already increased floor depth to do the spanning, it is usually discarded, and people end up putting columns in the middle of it. It's considered more, economic. But that need not be so if one adopts this system, as I say. By responding to the logic of the structure, which certainly doesn't need these deep beams, which are needed in the middle. There's no earthly need for that to continue to the point of support. In fact, it's undesirable. What you do need is a shear band, which we provide. Now let's look at the inside of the tower. What people pay high rents for, as I say, is unobstructed views. No Venetian blinds, sun protection to take the worst of the sun away at critical times of the year. These open spans, of course, simply show that you can do almost anything with 1,600 square meters of floor net. You arrive in lifts, and then it's up to the individual who can, you can subdivide it, or you can have open space of almost any description. And, this simply shows that the glass goes to within 300 or so, 300 millimeters of the floor, and the downturns of the sunshades come no lower than 1900 from the floor. And inside such floors of openness, almost anything can be done. You can get a tenant who wants the most extraordinary arrangements, and all of that is, of course, possible in column-free spaces. I believe that the future will keep such buildings more usable, even if the air conditioning wears out, the lifts wear out, and after 25 years you've got to renew all these things. But if you have a structure that allows this total flexibility, even though people redecorate and reuse, nobody quite knows what's going to happen in 50 years from now to these buildings, but unless people start growing 10 feet tall, they'll always remain usable. And I feel that's important. Now, here at the top of the building, and I think you may have seen that before, some extraordinary things happen because there are certain tendencies that have suggested connecting floors to each other. There are some that want trees to grow outside gardens, outside their offices, and without interrupting the system. You never interrupt the system of construction, but you simply leave out certain elements if need be, and you can, by special means, that interconnect floors to result in an open flow of space within these buildings that can be highly dramatic. I'm just showing another example of where this kind of thing has been done. Now, lastly, I think I'd like to look at this parking structure that I mentioned. It's across the space in Hay Street. You can see the building here. It's a long, deep building, totally prefabricated, 3 spans, a split level arrangement between them, and there's a hilltop at the top, and there are 2 levels of pedestrian bridges that connect back to the pedestrian precinct of the project. So anybody can arrive in his car and walk straight across on the cover and can reach the tower on the cover, or walk past the restaurants and so on to do that. What authorities are loath to accept these days, especially in Perth, are these bridges across streets. There have been some pretty horrendous ones built there. They're very unsightly, and we hope we have a better answer here that again gives some evidence of what happens. This is a long span beam, really, a channel-shaped beam, the top flange of which is logically widened out in the middle. It's a concrete beam, and that not only, I think, makes sense, but it's also a beautiful thing to do. There are 2 of these bridges with sort of a flanged channel on its broad side. That, I think, makes a good bridge profile. Most of this technology and the expressiveness of some of these gathered columns and this bridge here emanates from many years of association with Piero Ginervi in Rome that I worked with for a number of our projects. He's now dead, of course, but his one-time partner was instrumental in helping us with this project. Well, thank you very much.